am I gonna show you today. So as you can see on your screen, this is the model that we are going to make today. It is an excavation model. The excavation is being done in 3 different stages. The 3 different stages of excavation. So this is how we are going to prepare the model. The model contains several soil layers in terms of alluvial layer, weathered soil layer, weathered rock layer, and the soft rock layer. Also, we have several anchorages, and we have an edge pile that will be installed before the excavation will be done. So let's start the modeling in MIDASoftWorks. So first of all, we'll open MIDASoftWorks. So I double clicked on the icon of MIDASoftWorks, and I'm opening MIDASoftWorks. Once you open MIDASoftWorks, you will see that there are different modules to choose from, and you can choose the tunnel module because all the finite element modeling can be done in tunnel module. So I'm going to select the tunnel module. Once you select the tunnel module, you can select the parameters, the initial parameters for the model. You can define the unit system for force and length. In this project, we are going to keep the unit system as kilonewton meter, but let me tell you how you can change it. If you want to change it, you can just click on user defined, and there are different force units and length units that you can choose from. And once you click on OK, you will see that the force unit system and the length unit system has been updated. So once I click on OK, I'm inside MIDASoftWorks now, and I'm going to follow the set procedure of modeling in MIDASoftWorks. So first of all, I'm going to define the ground material property. For defining the ground material property, I'll go to Model, and I'll go to Ground Material Property. And here I can type in the name of any soil layer that I want to define. I can select various model types. The different constructive models that MIDASoft provides are listed here. You can define the general parameters and the additional parameters depending on the constructive model that you have selected. In this tutorial, we are going to use the database materials that are provided built-in MIDASoftWorks, and you can see that there's a list of materials that you can choose from. So here I'm going to select the list materials, and I'm going to select alluvial layer from it. I'm going to select the weathered soil, the weathered rock, and the soft rock. So these are the 4 soil types that I have selected from the database of MIDASoftWorks. And once I have clicked on the select, I have checked on the box for it, I can click on assign, and you can see that the 4 material properties have been assigned by the program automatically. So this is how you can define the material properties in MIDASoftWorks. The second step is to define the structure property. So for defining the structure property, I'm going to go to Model, Structure Property, and I will define the different structural properties that I need for this tutorial. So first of all, I'm going to define the pipes that are inside the model. The element type would be beam. I'm going to select the standard as AISC ASTM standard. The horizontal spacing between the pipes would be 1 meter, and this spacing would be out of plane of the model. The section shape would be rectangle, so I'm going to select the shape as rectangle. I will select H as 0.03 and B as 1 meters, and I can define the material data. For defining the material data, I have 2 options. Either I can define a user-defined material, or if I want to define the material from the code, I can select the material type as steel, and I can select the standard from the code itself. So this is how I have defined the pipe material. Now I'm going to define the pile section. For that, I'm going to give it a name H pile, and the type of material will be beam again. The horizontal spacing would be 1.8 meters. The section shape would be H, and I'm going to punch in the various dimensions of the section. So here I'm punching in the several dimensions. So this is how I have punched in the different dimensions of the H section based on the drawing here. And again, we are going to select the material type from the database, and I'll click on add, and you can see that now I have 2 different structural properties. The third property that I'm going to define is anchor property. For anchor, we are going to have 2 different types of element type. So the first element type would be truss, where I'm going to define the anchor as a truss, and the horizontal spacing would be 2.7 meters. The section shape would be user defined, and I'm going to define the area of the truss. So here I'm defining the area of the truss as a user defined input, and I can select the material as a user type. So here I'm keeping the default properties. If I want to change the properties, I can change the properties too. And once I click on add, you can see that the anchor has been defined as a truss type. Now I'm going to define an anchor as an embedded truss type. For that, I'm going to select this element type as embedded truss. The horizontal spacing and all other things would remain the same, and the shape that I'm going to select again is user defined, and I'll go to section data and I'll put in the same area. So basically I have defined two different types of anchor elements. One anchor is a simple truss element or a simple truss element type, and the other anchor is an embedded truss element. So I can click on that and you can see that two elements have been defined. So this is how we have completed the definition of structural property in MIDASoft. I'll be taking your question towards the end of the session, so let us, you can type in the question at any point you want, and I'm going to take up all the questions towards the end of the session. So when I go to the workstream here, you can see that we have 4 different ground material properties and we have 4 different structural properties, and you can see the different types of element type for the structural property. Now I'm going to define the geometry. For defining the geometry, again we have 2 different options. Either we can create the geometry by using the CAD modeling features of MIDASoft, or we can import the geometry. So for this training, we are going to import the CAD drawing file, wherein I have defined all the lines that I need in my project. So you can see that I have imported the CAD file and all the lines that I need in my model have been imported. Now I'm going to create the surfaces out of these lines. For that, I'm going to go to Geometry, Smart Surface, and in this way all the surfaces have been created by MIDASoft. So right now we have defined the materials and we have created the surfaces, but we haven't assigned the material to a particular surface. For that, we are going to select individual surfaces and we are going to assign the materials. For selecting the surface, we have 2 different options. The first option is you can create a rectangle around the area or the surface where you want to define the material property, and you can assign the material. The second option is you can just you can left click on the mouse and move it from right towards left, and you can select the surface like this. So I'm going to select all the surfaces where I want to define the alluvial layer, and I'm going to drag and drop the alluvial layer into the surfaces that I have selected. Now I'm going to select the surfaces for weathered soil. So here you can see that I'm selecting all the surfaces for weathered soil, and this is how the surfaces will be selected and defined. Now I'm going to select all the surfaces for weathered rock. So here I'm selecting the surfaces for weathered rock, and I will drag and drop the weathered rock material onto them. And finally I'm going to select all the surfaces for soft rock, and I will drag and drop the soft rock properties to the surfaces. You can click on the add on the left of different materials, and you can see the different surfaces that have been assigned the different material properties. Now I'm going to assign the material properties to the H file. So I'll select the curve on which I want to assign the element as H file, and this is how the element will be assigned. You can see the 9 curves which have been assigned the structural property as H file. Then I'm going to select the 2 pipes that we have in our model, and I'm going to assign the structural property as pipe to both of them. So this is how we have completed the definition of different materials to different parts of the model, and you will see here that we haven't used the anchor and the anchor embedded truss structural property, but I'm going to tell you how we can use them later during the modeling. So as of now we have defined the material properties, we created the surfaces, we assigned the material properties to them, And now we are good to perform the meshing. For performing the meshing, you can go to model and you have various options that you can choose from. You can select auto mesh, you can select map mesh, grid mesh, or pattern mesh. But if you want the program to automatically mesh the surface for you, you can just click on smart mesh and you can select the refinement as very fine, and once you click on OK, you will see that all parts of the model have been meshed. Now let us see the different mesh elements that we have obtained in this model. If you click on the plus sign on the left of mesh set, you will see that the different meshes that have been created by the program. Now let me tell you how these different mesh sets are created. So if we talk about the top layer, which is composed of alluvial soil, you will see that there are different subparts of the soil, and MIDASoft have provided a different name to different mesh set. So here you can see that the first alluvial layer is this one. So if you check on the mesh set, you can see the alluvial layer, which have been named as alluvial layer. Alluvial layer 1 is this part, and since you can see the other parts of the model. Now what I'm going to do is I'm going to rename some of the mesh sets so that I can identify them while I do the construction staging. So first of all, I'm going to define the mesh sets based on the excavation process. So I'm going to rename only the mesh sets which I need for modeling the excavation. So first of all, as I said before, the alluvial layer, this part of the model, it is going to be used as the first excavation mesh. So I'm going to select this alluvial layer. I'll tap F2 from the keyboard and I'll rename it as Excave1. So this is how I have renamed the excavation 1. Now I'm going to select the alluvial layer 1, which will be the first part of second excavation. So I'm going to rename it as Excave2-1. Now I'll search for the weathered soil component which has to be excavated in the second and third excavation process. So weathered soil, the element name is weathered soil. If you can see, this is the part which is the first excavation layer for excavation 3. So I'm going to rename it as Excave3-1. I'm going to see the different layers now, and I'm going to, okay, so soft rock 1 corresponds to the third layer of excavation 3. So I'm going to rename it as Excave3-3. The weathered rock layer, it will be the excavation, the second layer of excavation in the third process. So I'm going to rename it as Excave3-2. And finally, we are left with only one mesh set that has to be renamed as far as the excavation is concerned, and it is weathered soil 1. So it will be the second layer of excavation 2. So I'll rename it as Excavation2-2. So let us see what excavation names that we have provided in our model. So I will hide all the layer sets that I have, and I'll just keep all the mesh sets. So excavation 1 will be the first layer of alluvial soil. Excavation 2 would be comprised of 2 different mesh sets, and excavation 3 would be comprising of 3 different mesh sets. And when I uncheck them, I can see the excavation process. So this is not defining the construction stages. I have just checked off some mesh sets to see whether I have renamed them correctly or not. Now let us talk about the area where the pipes are installed in this structure. You can see that on the top in the alluvial layer we have 2 different sewage pipes, and there would be some alluvial soil inside them too. So before the pipes have been installed, the soil will be there, but after the pipes are installed, the soil will be gone from that area. So let us rename these 2 parts of the alluvial mesh sets, alluvial layer mesh set, so that we can deactivate them in the required construction stages. So I'm going to rename it as alluvial pipe 1 and alluvial pipe 2, so that I get to know that which mesh set contains the alluvial soil layer which has to be deactivated in when we install the pipes. So this is how I have renamed all the methods that I wanted to rename in this model. So it's pretty simple. You can rename it at your own wish. You can keep the names as you want, because MIDASoft has a standard set of principles, the standard protocol that MIDASoft follow to define the mesh set name, but you can modify them at your own wish at any time when you do the modeling. So as of now, you can see that we have defined the meshes and we have renamed the mesh sets according to our wish. And now let's create the anchorage system. For creating the anchorage system, we will go to model and we will go to create element. So we are going to create the element for anchorages, and let me first tell you the anchorage. One anchor has been divided into two different segments. One part of it has been anchored to the ground. So the part of the anchor which corresponds to the soft rock and the weathered rock, it has been anchored to the ground, and the length of the anchor which goes into alluvial soil and weathered soil, it is not anchored. So I'm gonna first create the mesh set name as level 1 stress free length, and I'm gonna select the anchorage length which is in the weathered soil and the alluvial layer. So when we talk about the first anchor, you can see that it ranges from this node to this node, and I'm gonna select create an element so that I can tell the program that there is an anchor at this location, but the type of anchor would be embedded truss element. I will select the structure property as anchor embedded truss, and I will click on 2 points, the 2 nodes, and you can see that the anchor element has been created. Similarly, I'm going to create the anchor element for the level 2 stress free length, and this time I'm going to define it for the second anchor that we have in our model. So this is how the second anchor has been defined. So again, you have to select the embedded truss element, the structure property as embedded anchor, and I will create the embedded anchor. So this is how the embedded truss element have been created. Now I'm going to create the level 1 anchored length for anchor 1. So I'm going to select the element type as truss element, and I'm going to select the structure property as anchor. So this structure property corresponds to the truss element only. So it is not the embedded truss element, but it is the truss element, and we can click on 2 different nodes ranging from soft rock to weathered rock, and you can see that this is how the level 1 anchored length has been defined. Similarly, I'm going to define the level 2 anchored length, and I'm going to select the truss element in the element type, and I'm going to select the property as anchor, and I'm going to define the second anchor length which is embedded in the weathered soil, the weathered rock, and the soft rock. Okay, so as you can see, let me once again tell you guys what do I mean by the embedded and the truss element in the anchor. So I just unchecked all the mesh sets. I'm going to activate only 4 different parts of anchors that I have in my model, and these are the layer sets. So as I said, the anchor in the alluvial soil and the weathered soil is going to be an embedded truss type. So I defined the property as embedded truss, and the anchor which goes into the soft rock and the weathered rock, it's gonna be defined as an anchored embedded type. So that's why I defined 2 different properties for structural property of anchor, one having a truss type and the second having an anchored embedded truss type. So I hope this is clear to you guys. So this is how we have completed the modeling of the anchors. The only thing that we are left with in this model is defining the interface properties. For defining the interface properties, we can go to model, interface element, And so the method would be create from truss beam elements. So whatever truss or beam elements we have in the model, the program will automatically generate an interface for them. So we have two different options of defining the interface. We can either define the interface using the define wizard, or we can define the individual property of the interface element. So we can either define the interface element property manually, or we can ask the program to create the interface property based on the ground material and the structure property. So here I'm selecting the method as create from truss beam elements, and I'll select the 1D elements which represent the H pile, and I will ask the program to create the interface property automatically. And once I click on OK, and I will give it a name, the mesh set will be interface. And once I click on OK, you will see that the new mesh sets for interface elements have been created, and Midas, the SolidWorks, has automatically created the different properties, the different interface properties for beam and truss for different materials. So you can see that once you go to the structure property field, you will see that Midas SolidWorks has created the property of interface elements for soft rock, weathered rock, weathered soil, and alluvial layer. So this is how the different properties have been created. And if you notice, there is one more interface element that has been created by Midas SolidWorks here, which is a rigid link of interface elements on both sides. By both sides, it means that we have two different mesh sets here, and before they are being excavated, they form the same system, they form the same layer. So Midas SolidWorks has provided a rigid link between these two mesh sets so that it can tell the program that before the excavation takes place, this is a continuous system. So that is why we have the rigid link on the interface elements on both sides of the H pile. So if you uncheck them, you can see that the red dot disappears, which represents the location of the rigid link. So this is how we have completed the modeling in this particular project. Now let us talk about the different loads that I want to assign. First of all, I'm going to assign the pressure load on this model. So I'm going to select the element boundary curve. I will select the different element where I want to define the pressure load. I will define the pressure load as 13 kilonewton meter square, and I'm going to give it a name, overburden pressure. So once I click on apply, you can see that the overburden pressure has been applied. Now I'm going to define the pretension to the truss elements that I have in this model. So the anchored are pretension. So I'm going to go to loads boundaries again, and I'm going to go to pre-stressed load, and I will select the name as level 1 pre-tensioning, and I will select the 1D element in the form of the level 1 anchor that I have. I will define the pretension force as 220 kilonewton, and I'll click on apply, and you can see that the pretension force has been defined in the first anchor. Similarly, I'm going to define the level 2 pretension in the second anchor. So I'm going to select the 1D element again, and I'm going to define the pre-stress of 220 kilonewton, and I'm going to check on the pretension so that it tells the program that it's a pretensioning that has been applied to this anchor. So once I click on OK, you can see that I have created the different load cases in the form of level 1 pretension and level 2 pretension, and you can just make sure from the worktree whether the definitions that you have done are correct or not. So this completes the load definition in this model. Now let us talk about the boundary. For defining the boundary, we have the smart support option. So I'll just select the smart support option, and in the boundary I'm gonna give it a name as support. And once I click on OK, you will see that the boundaries have been defined in the model. So this is how you can easily define the boundaries in MIDAS SolidWorks. Just go to Smart Support and you can define the boundary. If you want to define a particular support to a particular node, you can go to the support option and you can define a particular support to a particular node. So if you want to define the supports manually, you can use the support feature. If you want the program to automatically define the support, you can just go to the support feature in boundaries and you can define the supports manually. So it's pretty simple and convenient, and as of now we have completed the modeling of this project. Now let us define the construction stages. For defining the construction stages, we will go to Analysis Design, and first of all we'll define the different construction stages that we have in this model. For that I'll select the construction stage option and I'll click on Define New Construction Stage button, and I'm going to define 5 different construction stages. Once I click on OK, you can see that the 5 stages have been defined. So first of all, I'm going to click on Construction Stage 1. I will rename it as Original Ground because it is the original ground. So in the first stage, I'm just going to activate the different layers that this model has. And I'm going to check on Initialize Displacement. So basically I'm telling the program that whatever displacements that the program obtains due to the self-weight of the different layers, it has to be set to 0. So once I click on Modify, the original ground construction stage has been modified. Now I'm going to create the second construction stage as Install Structure. So I'll give it a name, Install Structure, and here again I'm going to check on Initialize Displacement. So whatever displacement that you obtained due to installing the structure, they'll be set to 0. And now I'm going to define the third construction stage, which is Excavation 1. I will click on Modify, Excavation 2, and Excavation 3. So this is how I have defined the 3 different excavation stages. But as of now, you have just provided the name of the different construction stages. You have not activated or deactivated different elements in it. So now we are going to do the same thing. We are going to define different elements in different construction stages. So for that, I'll go to Stage Models and I'll check on Simulate Each Stage. In the first stage, I'm going to put everything in terms of ground. So I'm going to put Excavation 1, 2, 1, 3, 1, and the alluvial layer in the pipes, the different mesh sets for different soils. So as you can see here, I'm putting almost everything in the first construction stage. I'm not going to put the pipe because pipe will be installed when in the second stage when the structure will be installed, and I'm not going to put the level 1 stress free length for the anchor. So I'm not going to put the anchor, and I'm going to put the interface link, which is a rigid connection between 2 different mesh sets, telling the program that they belong to the same body in this construction stage. So this is how the stage has been defined. You can see in the model view that we have all the 4 layers in this stage. Talking about the boundary set, I will define the ground supports, and talking about the load set, I will just define the self-weight in this stage. So you can see that whatever thing that you put in the activated data at current stage, it will be activated and it will be applied to the model. So I'll click on Apply and you can see that the first stage has been created. In the second stage, I'm going to install the structure. So I'm going to put in the beam for the pipe and the H-pile. So you can see in the model the beam and the H-pile appears. Whatever alluvial layer that was inside the pipe, that must be deactivated. For that, I'm going to select the alluvial layer inside the pipe that I activated in the previous stage to get deactivated. So I will put the alluvial pipe 1 and alluvial pipe 2 in the deactivated data at current stage, and you can see that they have been deactivated in the model. And Now again, I'm gonna deactivate the link that I created, the rigid link that I created between the two parts of the mesh, because now they have been separated using an H file, so the interface link will be deactivated. And here I'm gonna activate the interface L and R, which depicts the interface between the H file and the ground, and also the pipe and the ground. So I'll click on apply, and you can see that the stage has been defined. In this stage, we are also going to apply the overburden pressure. So I'll drag and drop the overburden load set into the activated data at current stage. I'll click on apply, and you can see that stage 2 has been defined. In excavation 1, I'm gonna deactivate excavation 1 mesh set. So I'll put it at deactivated data at current stage. And in activated data at current stage, I'm gonna put in level 1 stress-free length. So the first anchor would be put in, and the level 1 anchored length will also be activated. And also I'm gonna go to load set, and I'll activate level 1 pretension. So when we are installing this anchor, we are going to pre-stress it. So that's why I have activated the load set level 1 pretension in this construction stage. So I'll click on apply, and you can see that the first stage has been created. I'll go to excavation 2, and I will deactivate the mesh set excavation 2.1 and excavation 2.2, and you can see that this is how the excavation has taken place. And here I'm going to activate level 2 anchored length and level 2 stress-free length, so that I can activate the anchor for stage 2, and I'm going to activate the pretension that I have applied to anchor 2. And once I click on apply, you can see that we have defined the stage 2 of excavation. The third stage of excavation, I'm gonna deactivate excavation 3.1 mesh set, excavation 3.2 mesh set, and excavation 3.3 mesh set. So this is how the 3 different construction stages have been defined in this model. Now let's go and simulate these different construction stages to see whether we have defined everything appropriately or not. For that, I'm gonna go to analysis design, I'm gonna go to simulate construction stages, and I will select different construction stages, and I can see that the definition that I have done in different construction stages are fine. Okay, so looks good, everything looks good till here. The only thing that we are left with here is defining the analysis case. For defining the analysis case, I'm gonna go to analysis case, and I'll click on add, and I will use the analysis method as construction stage analysis. I'll give it a name excavation, and I'll go to analysis control, and I can punch in the different parameters for analysis control. The initial stress for stage for stress analysis would be original ground. We can check on the K0 condition to perform K0 analysis, and this is how the different parameters for analysis control will be defined. And I will select the type as construction stage analysis, and once I click on OK, you can see that the analysis case has been defined. And now I can run the model by clicking on perform analysis, and the program will perform analysis. So first of all, I'll save it, and you can see that the analysis is being performed and the analysis completed. So let us see the different results that we obtained from this model. So here, when you go to the results tab in the works tree, you can obtain the several results that you would like to see in this model. So in the original ground, if I go to displacements, I can see the different displacements. Then I can see the displacements or stresses when I install the structure. Let's see the displacement in level 1 excavation. So I'll double click on total displacement, and this is the displacement in level 1 excavation. Level 2 excavation, again I can go to displacement and total displacement, and this is the displacement in level 2 excavation. And similarly, I can see the displacement in level 3 excavation. If I want to obtain the stresses, I can go to ground element stresses, and I can obtain the different stresses. If I want to obtain the forces and piles and anchors, I can go to beam element forces, and I can go to either axial forces, or if I want to obtain the moment, I can obtain the moment. So I can double click on beam element forces and I can see the moments. If I want to see the results in truss element, I can go to embedded truss and I can see the different forces in truss elements. So this is how you can obtain the forces in truss elements. If you want to obtain the strains, you can obtain the strain also. So just go to the strain tab and you can obtain the strains in this model. So this is how we have done the excavation in MIDASoft. If you want to consider the water level, you can define the water level and program will consider automatically while performing analysis. If you want to perform the coupled analysis, you can first define the different stages in the C-page module and just change the module to tunnel module to perform the analysis again, and you can take into account the coupled analysis for your results. So this completes the training for today. If you guys have any more questions, if you guys have any question for the training of today, or if you guys have any other question regarding any other module, please let me know. Okay, so I can obtain, I have certain questions here, and the first question is, can we include lagging between H files? So by lagging, I hope you mean that the spacing in the z direction for the piles. Yes, the spacing between the z directions of the piles can be modeled. For that, when you define the structural property, when you go to H pile, let's say, you can see that we have defined the horizontal spacing as 1.8 meters, and this is the distance between the two piles in the z direction. And when the program makes the stiffness matrix, it obtains the stiffness for unit width, and it takes into account the distances between the two H piles in the z direction that is out of plane in this model. So if I answered your question, if I understood your question correctly, please let me know, but if you want to give some more details about this question, please let me know. I got a couple more questions. The first question is it possible to assign a non-uniform section along pile, like in the case of a drilled shaft socketed into rock? Or it's from the foundation module. Let me check it in the foundation module and I'll reply back to you within a minute. Okay, so the answer to the question whether we can define non-uniform section along the pile in a drilled shaft socketed into the rock. Well, we can define a uniform cross section along the pile, but we are trying to think how we can work around with it so that we can change the stiffness of the pile section uh, along the depth of the layer to possibly include this thing. And I'm gonna write an email to you about it, so I'll describe my answer in detail. So please wait for my email. Okay, so the second question that I have here is from Juraz. The question is, the lagging is defined the support between the piles. So can we model that in MIDASoft? We cannot model the lagging between the piles because it's just a 2D model. So what you can do is you can create the 2D cross section at different locations and you can simulate this behavior. So basically you will have to create the section at different locations and then you can take into account the lagging. Okay, so I just cross-checked in the foundation module again. So if I want to apply the non-uniform section along the pile, we can define the pile section as a tapered section and then we can assign the pile as a tapered section to define the non-uniform section along the pile length. So I hope it answered your question, Mr. Montesi. Okay, perfect. And talking about the lagging again, since I said that it's a 2D model, the lagging will not be modeled, but what we can do is this is the cross section at the location of a pile, but but if you want to take into account the lagging, what you can do is you can model a cross section where the pile is not present and then you can obtain the results for the same. But since it's not a 3D model, you cannot model the laggings. I hope I answered your question, Juraz, but we can talk more about it if you want. So I hope today's training was good for you guys. You guys could understand the part of it and maybe you can apply this thing to your real practical problems now. If you guys have any more questions, you can just email us and our email address is midasoft@midasuser.com and we'll be more than happy to answer any of your question in detail. So once again, I thank you all for joining the training with us. We will send you the invitation link for another training of Midas SoilWorks shortly, and hopefully we'll have this training somewhere in next week.